For this week's interactive advanced concept assignment, we had the opportunity to create ferrofluid. This presentation will discuss why the magnetic fluid occurs. For this experiment, I used some ink toner, vegetable oil, and a rare earth magnet. I first poured a little bit of the ink toner into a cup. I then added a little bit of vegetable oil to that cup as well, and mixed together until I had a nice thin consistency. Once it was all mixed together, I transferred it into a smaller cup. I then took the rare earth magnet and put it onto the bottom of the cup, and here was the result. So, how does the ferrofluid magically transform into spikes in those interesting shapes? We can think of it as a very careful chemical balancing act involving many different forces all hitting a sweet spot. Imagine that we applied a magnetic force to a ferrofluid as we did in the video presentation above. Here are several of the key interactions that happen. The magnetite acts as a magnetite does and is attracted and/or repelled based on the magnetic field. All those little nanoparticles respond to the force and start moving. The surfactant, or in the case of this video, the vegetable oil, remains ultra slippery and refuses to let the nanoparticles attach to each other. They continue to slip away while they move, forming quick bonds with the surfactant to become a special type of ligand, or a coordinate bond with a metal atom. At the same time, the surface of the ferrofluid experiences a lot of surface tension, which allows the fluid to maintain shapes for longer periods of time when it is drawn out. Meanwhile, van der Waals forces are having similar effect on the molecules within the mixture, allowing them to maintain a surprising amount of cohesion as the ferrofluid moves. On top of it all, as the ferrofluid is being pulled by the magnetic force, the heaviest parts are also being dragged back down by gravity at the same time. When you add it all together, you get a dazzling display of spikes, rivulets, and magical behavior as seen in the video. Additionally, the fluid is what is known as superparamagnetic, which means that, unlike normal magnetite, it loses its charge every time and collapses back into a fluid, unable to hold a permanent magnetic stabilized form. Ferrofluids weren't originally designed for fun. They can be created from iron, cobalt, nickel, and a variety of different oils and surfactants, giving them a variety of applications in the industrial world. The most important is probably their use in semiconductor manufacturing, where the fluid is used to seal powerful hydraulic machinery and other components to increase power, all while preserving contamination. For example, large fancy speakers, sometimes these loudspeakers use a magnet surrounded by ferrofluid. This keeps the magnet cool and helps prevent unwanted vibrations. It was interesting to discover when doing additional research for this assignment that in the future, scientists actually hope to use ferrofluid as a transmitting material for chemical treatments in healthcare. For example, by allowing doctors to control exactly where a drug is focused in the body. So the video that was shown earlier is actually our second attempt at this assignment. Originally, we were trying to save money. We don't have a printer that actually uses toner, and so rather than going out and buying a $65 to $100 cartridge of ink toner, we attempted to take old cassette tapes, remove the tape from inside them, and soak that in at 100% acetone. After doing some research online, we found that doing this would actually allow for the iron oxide to be extracted from the cassette tape and would leave the iron oxide as a thin residue on the bottom of a bucket. However, it is definitely a labor of love, as we had soaked 10 cassette tapes in 100% acetone all day, and regardless of how long, we were only able to gather a very, very small amount of iron oxide from this procedure. So I actually borrowed some ink toner from an old cartridge at the hospital, and though it was not very much, it was able to produce the results in this experiment. Thank you.